Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. For this week, we will be discussing on chapter 10 on the characteristics, processing and applications of polymers. Lastly, on the fourth part, we will now look at some of the applications of polymers. The last part of this chapter on polymer is on the polymer applications. So, based on the understanding of polymers, we can see that thermoplastic and thermoset, which are classified as plastic materials, they are the largest number of different polymer materials that comes, and plastics are polymer materials that have some structural rigidity under load, and they are used in general purpose applications. And these plastic materials may be either thermoplastic or thermoset polymers. For the elastomer, as we have described earlier, they are expanding in large percentage greater than 200% of deformation. And based on the uniqueness and the features of these major types of polymers, we can now relate to the application of polymers. So on this slide, we can see some of the examples of application from the automotive applications to the medical sector to the electronics to food packaging. But if you look around you, you will find that there are too many things that are now depending on polymers, including what we wear, what we use on our eyes, like our spectacles, like our screen, our smartphones, right? The clothes that we wear, the books. So many things today are made from polymers. The slides here gives us more ideas about some of the trade names, characteristics, and typical applications for several plastics, which are extracted from Table 15.3 in the Callister textbook. So we have, for example, acrylics, PTFE, nylon, polycarbonates, polyethylene, polypropylene, polystyrene, vinyl, PET, ABS, epoxy, phenolics, and polyesters. Okay, so the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are examples of the thermoplastic materials, whereas down the three materials down here are from the thermosetting polymer groups. So we can see and have ideas about their major application characteristics and the typical applications of each. For example, nylons are used for bearing, gears, cams, bushings, handles, and jacketing for wires and cables because they have good mechanical strength, abrasion resistance and toughness, low coefficient of friction, absorbs water and some other liquids. While materials like polycarbonates, they are used for safety helmets, lenses, light globes, base for photographic films because they are dimensionally stable. They have low water absorption, they are transparent, they have very good impact resistance and ductility, and chemical resistance are not outstanding. Other common polymer materials are polypropylene. They are resistant to heat distortion, they have excellent electrical properties and fatigue strength, they are chemically inert and relatively inexpensive, but they have poor resistance to UV light. So they are used for sterilizable bottles, packaging films, TV cabinets, and luggage. For polystyrenes, I think you are very familiar with polystyrene. They have excellent electrical properties and optical clarity. They are good in dimensional stability and relatively inexpensive. So they are used for wall tile, battery cases, for toys, indoor lighting panels, and appliance housing. Whereas vinyl, our laminated floor, they are good low-cost, general-purpose materials, ordinarily rigid, but may be made flexible with plasticizers and often co-polymerized and susceptible to heat distortion. The applications are like floor coverings, pipe, electrical wire insulation, garden hose, and phonographic records. For the thermosetting polymers, one of the main and most common type is the epoxy. It's also known as araldite, which is excellent combination of mechanical properties and corrosion resistance, dimensionally stable, have good adhesion, relatively inexpensive, good electrical properties, and the typical application for epoxies is that it has electrical moldings, sinks, adhesives, protective coatings, and used with fiberglass laminates. For phenolics, it's also known as bakelite. It has excellent thermal stability to more than 150 degrees C and may be compounded with a large number of resins, fillers, and therefore they are inexpensive. Therefore, they are used for motor housings, telephones, auto distributors, and electrical fixtures. Lastly, for the polyester from the thermosetting polymers, we are looking at Laminac, Aeropol, as in the trade names, and they have excellent electrical properties and low cost. They can be formulated for room or high temperature use and often fiber reinforced. So they find applications for helmets, fiberglass boats, auto body components, chairs, and fans. Next is some of the characteristics and typical applications for 5 commercial elastomers. Number 1 is the natural rubber or natural polyisoprene with elongation between 500 to 760%, and they have useful temperature range from -60 to 120 degrees C. The major application characteristics is that this natural rubber, they have excellent physical properties. They have good resistance to cutting, gouging, and abrasion. They have low heat, ozone, and oil resistance, and good electrical properties. And they find applications especially in the tire industries as pneumatic tires and tubes, heels and soles, and gaskets. For the styrene butadiene copolymers, or known as GRS, with elongation between 450 to 500, they have useful temperature range from -60 to 120. And some of the major characteristics is that it has good physical properties, excellent abrasion resistance, not oil, ozone, or water resistant. Electrical properties are good but not outstanding. And the typical application is similar to the natural rubber. For the NBR or acrylonitrile butadiene copolymer with elongation between 400 to 600% and useful temperature range from -50 to 150, they have excellent resistance to vegetable, animal, and petroleum oils, poor low temperature properties, electrical properties are not outstanding, and the typical applications are for gasoline, chemical and oil hose, seals and O-rings, heels and soles. And we have neoprene and silicone. Silicone is also very significant in medical industries. The other name for silicone is polysiloxane, the chemical name. And the elongation is between 100 to 800%, and they find useful temperature from -115 to 315 degrees C. The characteristics are it has excellent resistance to high and low temperatures. They have low strength, however, and excellent electrical properties. So some of the typical applications are for high and low temperature insulation, seals, diaphragms, tubing for food and medical uses. Now, let's look at the specific example of application for advanced polymers, and it's called the ultra-high molecular weight polyethylene, or UHMWPE, which has molecular weight of 4 times 10 to the power 6 gram per mole. Some of the outstanding properties of this material is that it has high impact strength and the resistance to wear or abrasion, low coefficient of friction, and self-lubricating surface. And some of the important applications for this material include the bulletproof vest, golf ball covers, and the hip implant, that is the acetabulum cup as shown on this figure here. Now, we are discussing on polymer additives. The reason why we have polymer additives is to improve the mechanical properties, processability, and durability of polymer. Unlike metal, where we use heat treatment and we add alloying elements to it, so for polymer, the route to improve or enhance is through adding fillers, for example, to add it is added to improve the tensile strength and abrasion resistance, toughness, and to decrease cost. Examples are carbon black, silica gel, wood flour, glass, limestone, talc, and etc. Second is the plasticizer. This is added to reduce the glass transition temperature or TG below the room temperature. And the presence of plasticizer transforms the brittle polymer into the ductile one, and it is commonly added to PVC because it is otherwise brittle. We also have stabilizers added, and they are either antioxidants or UV protectants. And lubricants are added to allow easier processing. For example, during the compression molding, or injection molding, or extrusion, we need to add lubricants to have polymer slides through the dies easily. In example, the specific example of lubricants include the sodium stearate. We can also have colorants like the dyes and pigments. You can beautifully see them in the different range of applications that we use, which are made from polymers. As simple as our Lego toys at homes or bricks, and so many other things that we are now wearing and continue to wear and depend on. They are all made from polymers. For flame retardants, we can have substances containing chlorine, fluorine, and boron. Lastly, let's look at a summary of the chapter from the approach of structure, properties, process, and applications. We know that they are interrelated as we discuss about one another. So to recall, I would like to highlight some of the important aspects from the chapter that begins with understanding on the structure of polymers. Before we can appreciate the structure of polymers, we must first be able to define the main classes of polymers, that is either plastic or elastomer, that is either thermoplastic or thermoset, and for the thermoplastic, it is either crystalline or amorphous. And in terms of the molecular chain structure, we know that they can exist either in linear branch, that is for the thermoplastic, cross-link or network, that is for the thermoset. And because of the difference in terms of the molecular chain structure, it is affecting the degree of polymerization and the molecular weight, and also the degree of polymerization has a strong effect on the properties of polymers. And we have discussed in terms of the thermal properties, especially when we discuss on the Tg and Tm of the fully crystalline, semi-crystalline, and amorphous polymers. And we have also discussed on the mechanical properties of polymers. We know that some polymers like the thermoset material, they are the stiffest and also the most brittle type. The plastic material, the thermoplastic material, are more ductile and have average or moderate strength, whereas the elastomer material, which is expanding greater than 200%, is very, very weak in terms of the mechanical strength, but they have a lot in the ductility. We have also relate the properties with a suitable process of each. Compression molding, extrusion, injection molding, extrusion, blow molding are some of the main processes suitable for thermoplastic and thermoset materials. And thermoforming, calendering, and spinning are some other common processes applied for the polymer materials. For the example of applications, there is a widespread spectrum of applications, and some of them include in automotive, food packaging, electronics, medical, consumer goods, and etc. Therefore, to sum up, we have discussed first on the polymer molecular structure, we have classified polymers, we have looked at how we synthesize polymers, either to addition or condensation. We have also looked at sample problems relating to how we can calculate for the molecular weight and the degree of polymerization. We have also discussed in terms of the polymer crystallinity, polymer melting and glass transition temperatures, which is affecting the thermal properties of material, and look at the mechanical properties of materials based on the three classifications. We have then discussed briefly on the different polymer processing, including the extrusion process, the compression molding, injection molding, and blow molding. And lastly, introduce you to some of the applications of polymers that is widespread and covers all industries involved. With that, I hope that you have enjoyed and have learned somehow on the polymer classification, process, and applications. Thank you. Bye for now.